Alright, this question is number 8, homework number 3. This took so long. So, we want to know the force that Betty pulls, essentially. If Charles is pulling in the direction drawn or the other possible direction of equilibrium. Let's just first worry about the direction drawn. So, we do not know what Betty's pull is. However, we know if we were to keep the graph like this, Betty is only pulling in the y direction. So if we could figure out what Alex and Charles's y pull is, we could figure out Betty's, because since it's not moving, Alex and Charles's pull in the y direction must be equal to Betty's pull. So how do we find Alex's and Charles' pull? Well, I just put it down here just for reference. So Alex's pull will be sine whatever this angle is times by whatever Alex's pull strength is, which is in my case it's 211. Why sine? Because imagine this is the angle right here. Sine would be opposite over hypotenuse, and the opposite side represents the y area, so it would be sine. Why 142 minus 90? Because this is 90 degrees right here, and this whole thing's 142. So this angle is just 142 minus 90, which would be 52. And we can apply the same logic to Charles. However, with Charles, we do not know this angle. So, however, once we figured out Charles's angle, we could do this equation down here to figure out what By is, the strength that Betty pulls in the y direction. And since Betty's only pulling in the y direction, as we defined it, we would figure out Betty's total strength, which is what the question's asking. So we need to find the angle Charles is pulling up. So this is the key realization for this question. Betty is not pulling at all in the x direction. So the amount that Alex is pulling in the x must be equal to the amount Charles is pulling in the x. This is very useful to know because we can figure out how much Alex is pulling into the x direction. We already know the angle, and we already know the total magnitude. So we take the angle, which would be 52, or 142 minus 90, multiply it by 211. But why do we use cosine for x? Well, that's because x is the adjacent to this angle. This is the angle, adjacent is the x. So we know that a of x, which is cosine 52 times 211, is equal to c of x, which is this, which is basically the same as c is y, except we just used cosine. So then we must set these two equal to each other. If we set them equal to each other, we can find theta. We find cosine theta equals that, then we use arc cosine. If you were to use a calculator, you would get this. 44.458. So this angle right here is 44 point whatever you got. So now that we know the theta, we can just plug it into this equation that we had earlier. By equals sine of that. And if we go through the work, we'll find the strength that he's pulling at. There's about a 2% tolerance allowed for this problem, and as you saw, my answer here is ever so slightly off. That's just probably because of rounding. I wasn't able to replicate it, but off by like less than 1. An answer that's almost 300. That's okay. So for B, they're asking us, this question, a lot of people, including myself, was incredibly confused, but they were saying the other possible direction for equilibrium. Well, Charles doesn't have to be pulling here. He could be pulling this way, down. As a matter of fact, we actually know how to find this, because recall that we did cosine theta equals whatever you got. However, there's technically two answers for this. There's the positive answer, but also it could be negative 44.458. as equally as possible. And in this scenario, negative 44.458, it would be somewhere down here where Charles is pulling. That's also possible, and that's what this question is reminding us and also asking us. So we literally just need to go through the exact same work, except for theta we use negative 44.458. So same equation, except we replace that, and then we get our answer. And again, I was off by like a smidge, by about a bit less than 1. That's alright. We are allowed a small bit of error. It's probably just through rounding. And yeah.